Hi, hello. Today topic is rain and umbrella concept. Welcome to my channel, Nature of Physics and Art. Step by step, I will explain clearly and watch full video. You can easily understand with numericals. Okay, see here rain and umbrella concept we are considering. VR is the velocity of the rain and Vm is the velocity of the man. Rain is falling with a velocity Vr and man is moving with a velocity Vm related to the ground. He will observe rain falling with a velocity Vrm. Vrm which is equal to Vr minus Vm. So what is Vrm here? Velocity of the rain related to the man. That's why he will observe rain is falling with a velocity Vrm which is equal to Vr minus Vm. Okay, so then continuation we will discuss step by step the cases also. Okay, see now first case, that is case 1. In case 1, the rain is falling vertically, that is along the negative y-axis. Rain is falling downward direction and the man is moving along the positive x direction. Man is moving along the positive x-axis. We can consider if the man is moved, okay, left side, that is negative x-axis. That's why minus Vm is taken. In numericals we can discuss that kind of problems. Okay, so then here try to understand step by step. Vr is acting vertically, okay, and Vm acting along the horizontal direction. So we have to find the velocity of the rain related to the observer. So that Vrm. So this green line represent Vrm. So that is between the negative x-axis and negative y-axis. So here we can take the diagram clearly based on this diagram. So a man is moving with a velocity Vm holding an umbrella. Umbrella represent a resultant direction. Okay, so then here alpha and beta is taken. Beta is the angle made by the umbrella with the vertical and alpha is the angle made by the umbrella with the horizontal. Okay, derivation we can do step by step. Now try to understand. In the first condition, once again I'm repeating, here rain is falling downward direction and man is moving along the horizontal direction, that is rain is negative y-axis, man is moving along the positive x-axis. Okay, so clearly given three diagrams. Okay, see Vrm bar which is equal to Vr minus Vm. So Vrm bar which is equal to Vr bar plus minus Vm bar. Okay, Vrm bar, okay, magnitude I am writing now, that is root over Vr square minus Vm square. Diagonal square which is equal to side square plus side square. Diagonal is equal to square root of side square plus side square. Try to understand. Next we can write here the magnitude of rain relative to the man, that is Vrm which is equal to root over Vr square plus Vm square. So magnitude of, okay, only magnitude considering here. And next alpha and beta is there. What is beta? Beta is the angle made by the umbrella with the vertical. So that's why I'm going to write here tan beta which is equal to mod opposite is Vm divided by mod Vr, and alpha is the angle made by the umbrella with the horizontal direction. See, then tan alpha, which is equal to Vr mod Vr divided by mod Vm. Okay, so these are the very useful formulas when the rain is falling vertically downward direction, that is negative y-axis, and man is moving horizontal direction, that is from west to east direction. And please copy this. Now, second case. In the second case, the man is moving with a velocity Vm1 along the positive x-axis, that is from the west direction to east direction, that is Vm1. For negative, minus Vm1, that is from east to west. Try to understand. In this situation we are considering only from west to east, that is positive x-axis, that is Vm1 is the man moving with a velocity Vm1. Okay, see then continuation here. Vr, what is Vr? Vr is the velocity of the rain. Rain is falling with a velocity Vr, which is making an angle theta with the vertical. See, this is the making an angle theta with the vertical. Okay, now we have to find, that is resultant velocity, that is represent the direction of the umbrella. Okay, so that here velocity of rain related to the man represent the green line, that represent the umbrella direction with the vertical. Okay, that is taken as beta. Beta what here? Angle made by the umbrella with the vertical. What is theta? Theta is the angle made by the rain with the vertical. So clearly given in the diagram. Okay, even direction of the rain, and Vr1 is the velocity of the rain related to the man. Okay, so step by step we will do the derivation. See, so here Vm1 is the velocity of the man. Okay, Vr1 is the velocity of the rain related to the man, because of here we are considering Vm1 is the velocity of man. Okay, so then Vrm1 is equal to Vr minus Vm1. Okay, so then next one we can write Vr resolve into two components, horizontal component and vertical component. Vr bar, which is equal to Vrx I cap minus Vry g cap. Okay, Vrx is along the positive x-axis and Vry is along the negative y-axis. That's why here negative is taken here. Okay, then next Vm1 bar, which is equal to Vm1 into I cap only. This is only along the direction of the positive x-axis considering. Okay, that's why I only taken. Okay, then we have to find beta. And what is the beta here? Just now we did. Beta is the angle made by the umbrella with the vertical. That's why here tan beta, which is equal to the value opposite side divided by adjacent side. Opposite side, this value represent Vrx minus Vrm1. Vrm1. See, this distance is Vrx and less value is Vrm, then the result value is Vrx minus Vm1. So tan beta which is equal to Vrx minus Vm1 divided by adjacent side is Vry. Okay, so we can write here beta also, that is tan inverse of Vrx minus Vm1 divided by Vry. Okay, so this is the explanation for the rain making an angle theta with the vertical man moving from west direction to east direction, and please copy this. Third case we will discuss here. The man is moving from west to east direction, that is along the positive x-axis with Vm2, that is he speed up at particular velocity Vm2. Okay, see, and rain is falling with a velocity Vr, and which is making an angle theta with the vertical direction. And we can take Vrm2 is the velocity of the rain related to the man, that is Vrm2 which is equal to Vr minus Vm2. Try to understand here, the man is moving from west to east direction Vm2, and rain is falling with a velocity Vr making an angle theta, and here the resultant direction of the umbrella that represent Vrm2, that is vertical direction. That's why the rain will appear falling vertically along the negative y-axis, that is taken as Vrm2. This is the very simple case only. Third case, in this situation, here we can write resultant velocity, that is Vrm2, that is velocity of the rain related to the man, which is equal to Vr minus Vm2. Okay, please copy this. Now fourth case. In the fourth case, the man moving with a velocity Vm3 from west direction to east direction. Here directions taking in three cases from left side to right side, that is from the west to east direction. Okay, so that is along the positive x-axis. See now, here velocity of the rain is Vr, rain falling, which is making an angle theta with the vertical. So here man speed up its velocity, speed increasing. Okay, that's why here he hold the umbrella with an angle beta with the vertical. Okay, so the diagrams are three clearly given. Now we will discuss derivation. Here Vrm3 which is equal to Vr minus Vm3. He will observe the velocity of rain related to the velocity of man, that is Vrm3 which is equal to Vrm minus Vm3. And step by step we can discuss only that the speed increases, he will see the rain falling with velocity is Vrm3 already just now completed. And beta, what is beta here? Beta is the angle made by the umbrella with the vertical, so we can write here tan beta. So tan beta which is equal to, try to understand this value, we have to know that is from this point to here represent Vm3, and we are resolving to two component Vrx and Vry. So this is Vrx, opposite sides are equal, then resultant value from here to this point is Vm3 minus Vrx. So tan beta which is equal to opposite is Vm3 minus Vrx divided by Vry. Okay, here beta is taken as Okay, angle made by the umbrella with the normal. Please try to understand, and continuation numericals I can explain to you. Okay, with the diagrams clearly given. And in rain umbrella, major mistake student will do, that is based on the direction only. So try to understand the direction. Different kind of numericals we can do there. You can understand remaining applications also clearly step by step. Numericals based on the concept, that is rain and umbrella concept. See now, first question, that is, it is raining at a speed of 5 meter per second at an angle 37 degrees with vertical towards east. A man is moving towards west with a velocity 5 meter per second. The angle with the vertical at which he has hold the umbrella to protect himself from the rain is. See, try to understand according to the question. Here, this is the vertical. This is vertical. Okay, and rain is falling like this. This is the rain. We are velocity of the rain. Okay, and a man is moving, that is generally we took from left side to right side. Here the man is, according to the question, is given towards the west from the east, so that we can take here this is plus Vm and this is minus Vm. Okay, so then this is the angle given, that is 37 degrees. Okay, and what we have to find, resultant direction, that is here he have to protect the from the rain with the help of umbrella. The direction of the umbrella here like this. See, this is the Vr minus Vm resultant, that is velocity of rain related to the man. Think practically. Actually we took result value is left side in the previous cases because of the man is moving from the west to east direction. Here I took result direction is, that is umbrella direction from the vertical is taken outside the velocity of the rain. The reason is here man is moving from east to west direction according to the question. Please try to understand. Then this angle is taken as theta. So we have to find tan theta is our question. See, step by step we can discuss. Here Vr is equal 5 meter per second given, and Vm also 5 meter per second. Now I can write here sine 37, that is taken as this is x value and this is the y value. Okay, sine 37, which is equal to, that is x divided by Vr is 5. Sine 37 value is, opposite is 3 and hypotenuse is 5. 3 divided by 5, which is equal to x by 5. 5 get cancelled, x is equal to 3. Okay, and next cos 37 which is equal to y divided by Vr is equal to 5. Then continuation cos 37 is equal to, that is 4 divided by 5, that is y by 5. 5 get cancelled, here y is equal to 4 meter, here x is equal to 3 meter. Okay, we wanted to find tan theta, which is equal to, that is x plus Vm divided by y, and tan theta which is equal to x value is equal to 3 and Vm value is 5 divided by Vy value is 4. Then tan theta which is equal to here 2 theta is equal to tan inverse of 2 is our answer. Okay, this is the answer for the given question. Please copy this. Question. See, rain pouring down at an angle alpha with the vertical has speed of 10 meter per second. A girl run against the rain with a speed of 8 meter per second and see that the rain makes an angle beta with the vertical. The relation between alpha and beta. See, according to this question, this is the vertical. Okay, and this is the rain. So this is making an angle alpha. Here velocity of the rain is given as 10 meter per second and velocity of the man is 8 meter per second given. Okay, but according to the question, the girl is moving from the east direction to west direction. This is minus 8 meter per second. Try to understand. Here the resultant direction of the umbrella must be right side the VR, velocity of the rain. So that because of we did the cases in that the man is moving from left side to right. In the previous question, this question, the man and the girl, okay, moving from right side to left side, that is east to west direction is given. Okay, so we can take this is the resultant direction, that is the VR minus VM. This is umbrella which is making an angle beta with the vertical. So here asking the relation between alpha and beta. Try to understand like similar method only. Okay, so first I'm going to write sine alpha which is equal to, I'm taking this is the x and this is the y. Okay, so then here velocity of the rain resolve into two components, horizontal component and vertical component, that is x divided by 10 VR value and x is equal 10 sine alpha, and next cos alpha which is equal to y divided by 10 and y is equal 10, okay, cos alpha, and tan beta which is equal to opposite value is x plus Vm divided by y, and tan beta which is equal to x value is 10 sine alpha plus Vm value is 8 divided by 10 cos alpha. So this is the answer for the given question, and please copy this. See here, third example problem. A rain is vertically falling with a speed of 20 meter per second. A person is running in the rain with a velocity of 5 meter per second, and a wind is also blowing with a speed of 15 meter per second, both from the west. The angle with the vertical at which a person should hold his umbrella so that he may not get drenched is. See, try to understand. According to this question, here this is the velocity of the rain which is equal to 20 k cap meter per second minus 20 because of negative axis, z axis, and next here given, that is according to the question, this is the velocity of the man which is equal to 5 meter per second, and wind also flowing, that is velocity of wind, which is equal to 15 meter per second. See, try to understand. Next, I am going to write here according to the question. So, resultant velocity of rain and wind is, that is VRW, which is equal to minus 20 k cap plus 15 I cap. Okay, next I am going to write here velocity of rain relative to the man is, that is, we can write here VRW minus VM. VRW value is minus 20 k cap plus 15 I cap, and velocity of the man is 5 I cap. So along the positive x-axis. So then that is minus 20 k cap plus 10 I cap. So we can take, this is making an angle theta. This value, y-axis value we have, that is taken as here negative z-axis, and this value represent, that is 10. Okay, so from this equation, this is the first step, and this is the second step, and third step is tan theta, which is equal to opposite by adjacent side, that is 10 divided by 20, which is equal to 1 by 2. Tan theta is equal to 1 by 2, and theta is equal to tan inverse of 1 by 2 is the answer for the given question. Please copy this. Fourth question. See here. A man is walking at the rate of 3 km per hour. The rain appeared to fall vertically. When the increase his speed to 6 km per hour, it appeared to meet him at an angle of 45 degrees with the vertical. Find the angle made by the velocity of rain with vertical and its speed. Okay, what is asking here? Angle and also velocity of the rain. Try to understand here. First condition, according to the first condition, here this is the velocity of the rain, which is making an angle theta with the vertical. Okay, so then here we will get, this is a resultant value VRM. So that reason is here man is moving with a velocity VM from west direction to east direction. This is the third case, we did already based on that. Okay, so next, according to the question, second condition, that is given like this. See, this is taken as velocity of the rain. Okay, so this value is 3 km per hour. So negative value is how much? That is minus 3 km per second. So negative x-axis, this is the positive x-axis. Okay, see, try to understand. This is, we can take the value is 3 km per hour. So this is making an angle theta. If the person is increased his speeds from 3 km to 6 km, now he is moving with 6 km per hour. 6 km per hour. See, try to understand. In this situation, here the resultant direction of the umbrella with respect to vertical is taken as, this is beta. Okay, so this is also how much? Just increase double. That's why this value also must be 3 only. Try to understand. 3 plus 3 is 6. 3 plus 3 is 6. Okay, so this vertical value is taken as y. Here from the diagram, tan theta, which is equal to the 3 divided by y, and here this angle is given as beta 45 degrees according to the question. So tan 45, so tan 45, which is equal to also 3 by y. Okay, so then both values are equal here, so we can write tan theta, which is equal to tan 45. So theta is equal, we got 45 degrees is the first answer. And we have to find the velocity of the rain. For that, sine theta value is 45 degrees, which is equal to 3 divided by VR. Try to understand. So here sine theta is equal to how much taking? Here 45 degrees we got. Okay, then opposite by adjacent side 3 divided by VR. From this, sine 45 value is 1 by root 2, which is equal to 3 divided by VR, and VR is equal to 3 root 2 kilometer per hour is the second answer for the given question. Please copy this. Example problem. A rain is falling vertically with a speed of 1 meter per second. Wind start blowing after some time with a speed of 1.732 meter per second in east to west direction. In which direction should a boy waiting at a bus stop hold his umbrella? See, try to understand. So first condition here, this is the velocity of the rain, which is equal to 1 meter per second given. After some time, wind is from the east direction to west direction. So here this is taken as north and east, west and south. See, try to understand. The person must have to hold his umbrella between the two velocities like this, because of this is the resultant direction. So this value is taken as the resultant direction are taking, and it is making an angle theta here. Okay, so this is velocity of the rain with respect to we can consider, that is holding the umbrella a boy standing in the bus stop during the rain. Okay, see, try to understand step by step. We can discuss clearly here. Okay, first we have to discuss the VW and VR resultant value. So what is the resultant value? VRW, that is equal to VR square plus VW square, that is from diagonal square is equal side square plus side square formula. Then VR omega square, which is equal to this value is 1 square, and that value is given as 1.732, that is a root 3 value. Okay, meter per second, so we can write here root 3 whole square. Then VRW, which is equal to, that is 4, so then we can write here VRW, which is equal to 2 meter per second. We got this value is 2 meter per second. Now tan theta, which is equal to opposite by adjacent side. Opposite side is root 3 divided by adjacent side is 1. So theta is equal to tan inverse of root 3. Okay, so theta is equal to 60 degrees is the second answer. This is the first answer, and please copy this. See now, last question. A rain is falling vertically with a speed of 1 meter per second. A woman rides a bicycle with a speed of 1.732 meter per second, that is root 3 meter per second, east to west direction. What is the direction in which she should hold her umbrella? So direction asking how much angle she should hold the umbrella with the vertical in our question. See, in the previous question, that is, and this is the difference is what here, a boy is standing in a bus stop holding the umbrella to protecting from the rain. That is, the boy is rest position and the rain is falling vertically and the wind is started to move from the east direction to west direction. Here what is asking in the second question, this is the question in which here rain is falling, that is vertically 1 meter per second only, but instead of wind taken here, a girl with bicycle is moving from east direction to west direction. Then how much angle required to hold the umbrella to protect from the rain is asking. See, according to this question, this is the velocity of the bicycle and this is the velocity of the rain. This is given as 1 meter per second and this is equal to root 3 meter per second is given. Okay, so here we can take two components of the velocity of the bicycle, that is positive value is Vb, which is equal to root 3 meter per second, and negative value is minus Vb, which is equal to the root 3 meter per second. Try to understand. Here she should hold the umbrella like this direction, then only she can protect the she can protect from the rain, that is making an angle theta here. See, try to understand from this concept clearly. This is the V velocity of rain with respect to bicycle girl, that is taken as VRB, which is equal to VR minus VB, capital B taken. So here also take capital B. Okay, so then we can write tan theta, which is equal to opposite side is root 3 divided by adjacent side is 1. So simply we can write here tan theta, which is equal to velocity of bicycle divided by velocity of the rain. So then here theta is equal tan inverse of root 3, then here theta is equal to 60 degrees. 60 degrees is the angle of the umbrella with the vertical. Umbrella making an angle 60 degrees with the vertical, then only she can protect from the rain while doing the bicycling from the east direction to west direction. And please copy this and thank you.